Hey guys, it's Miss Cuban here. In this lesson we're going to talk about square roots. And when you're talking about square roots, you are talking about in the word squares. Okay? So squares. So if I have one square, my base, my side is 1, and my height is 1. So 1 times 1 is 1 squared, and that's equal to 1. That's a square. A square root is wanting just a side length. So the area is your square. Your area is the squares. The inside. And square root is wanting the side length. What side length of a square would give you the area on the inside? For example, in this problem, I have how many squares? I have 4. My side length is 2 by 2. So my side length is 2 by 2. So my area is 2 times 2, which is the same as saying 2 squared, and that's equal to 4, because I have 4 squares on the inside. Square root, this little symbol, of 4 means I have 4 squares on the inside, and I'm taking the square root of it, so I just want to know what my side length is. My side length is 2, so my answer is 2. Let's try some more. Okay, so now let's say we want to know what is the square root of 9. So I'm going to draw 9 squares together. 3, 4, 5, 6, and I want to get a perfect square. 7, 8, 9. My length is 3. My height is 3. So 3 times 3 is 9. So the square root of 3 times 3, which is the square root of 9, is equal to 3. Because 3 is my side length. Let's try another one. The square root of 16. Well, I want a perfect square. So how can I get 16 in a perfect square? Well, I know I can make a 4 by 4 to get 16. Because 4 times 4 is 16. So the square root of 16 is equal to 4. But Miss Cuban, some of these square roots are not perfect. How do we find the square root then? Good question. Let's find out. Okay, so I have the square root of 5. So I have my perfect square. And I know my perfect square, 1 by 1 is by itself. If I do a 2 by 2, that gives me 4. But I have 1 extra. So, my side length of the perfect square of 4 is 2. So, that would give me my whole number. So now I have square root of 4 plus 1. So 4 is 2. That's my perfect square. But I have 1 left over. I have 1 remaining. My denominator is the whole that it takes me to get another perfect square. So if I made the next one, which is a 3 by 3, we already had 4. That 1 left over was our 5th one. How many does it take to get the 3 by 3? 1, 2, 3, 4, 5. 5 is my denominator. I had 1 out of the 5th to make the 3rd one. Okay, Ms. Cuban, but how do you do it mathematically? Good question. Just like I wrote right here, square root of 5 is 4 plus 1. I know that the square root of 4 is 2. And I know that the next one for 3 would be the square root of 9. That means 5 is in between. So 2 is my whole number because it went in twice. 1 is my remainder because the square root 5 minus 4 is 1. And my denominator is my wholes. How do I go from 2 to 3? So 9 minus 4 is 5. 9 minus 4 is 5. That's the difference between them. Let's try one more. Square root of 11. 11. We're going to do this both ways, the model and the math. The model, I want a perfect square. So I have 11 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11. But I know that my perfect square was 3 by 3. That means my whole number is 3. My remainder is 2 left over. But because I know 3 was my whole number, I want to try to get to 4. So to get to 4, I have to add 1, 2, 3, 4, 5, 6, 7 more squares total. But remember, I already had 2 of those. That's why it's 2 sevenths. Part of the whole. Okay, so mathematically, I know, let's see, 1 squared is 1, 2 squared equals 4, 3 squared is 9, 4 squared is 16. 11 is in the middle of 9 and 16. So my whole number is 3. And my remainder is 11 minus 9 equals 2. And my denominator is 16 minus 9, the whole in between, which is 7. So square root of 11 is 3 2/7. So I hope this helps you guys with square roots, knowing where they come from. It is an irrational number because it's not perfect. If they are perfect squares, perfect ones, then they are whole numbers. But if they're not perfect, they're irrational. So why don't you try some? Make some numbers, find some square roots, and have fun with it. Have a good day, guys.